Built as the fastest way to cross the surface of the Earth, Hyperloop represents the greatest leap in transport infrastructure for generations, with passengers sitting in the pods that travel at airline speed through pressurized tubes. Using electric propulsion and magnetic levitation, the concept promises to slash journey times between major cities from several hours to a matter of minutes. Hyperloop was first conceived in 2012 by Tesla and SpaceX founder Elon Musk. In a white paper released the following year, Musk set out his vision for the futuristic super high-speed transportation system that would see passenger pods move through a partial vacuum in steel tubes, addressing the two key factors that slow down conventional vehicles' friction and air resistance. Under Musk's first Hyperloop proposal, he suggested that compression fans would move air around the passenger pods to minimize drag and create air bearings beneath them, floating them off the surface of the tube. With an estimated price tag close to $6 billion, Musk's first Hyperloop concept never came to fruition. But the impressive idea that potential to link cities in such direct way sparked intense interest. Now, several fully fledged companies are making significant strides to bring Hyperloop systems into reality. Hyperloop Transportation Technologies, or HTTT, are making aggressive advancements and recently constructed a full-scale test track in France. But the clear leaders of the pack in the current standings are Virgin Hyperloop One. Virgin Hyperloop One are on track to achieve their bold mission of bringing a Hyperloop system into operation by 2021. Originally formed in 2014 as Hyperloop One, the company was rebranded following a significant investment from the Sir Richard Branson in 2017. Creating slightly from Musk's original plan, Virgin Hyperloop One's technology combines two basic principles. The first is magnetic levitation, or maglev, a technology already used in monorails to lift the passengers' pods and move them along their rails. Magnetic levitation uses two sets of magnets, one to repel the train from the track and lift it upwards, and the other to move the floating train along the track at a considerable speed with reduced friction. The second principle is used to lower the pressure vacuum sealed environment for the passenger pods to travel through. By removing most of the air from the tubes and having no contact with the ground, the pods face little to no resistance as they move. Air pressure inside the tube are equivalent to flying 200,000 feet above the sea level. Such an environment enables the pods to reach speeds over 760 miles per hour using very little energy. By virtue of being in a tube, the system is protected from the weather and can operate in almost any climatic condition. Virgin Hyperloop One's system is controlled by advanced software that ensures acceleration and deceleration occurs gradually, going relatively unnoticed by those traveling inside. Having built a 500-meter track in the Nevada desert, Virgin Hyperloop One have carried out several tests focusing on individual aspects of the system and a complete full-scale system test in May 2017. The propulsion, braking, levitation and vacuum systems are all performing well, and the team have achieved a top speed of 240 miles per hour to date. To inform their plans of developing a fully operational network that is affordable for all, Virgin Hyperloop One launched a globally challenge to find the route's best place to benefit from Hyperloop technology. With over 2,600 entries, the field was reduced to just 35 potential locations, with each entry enjoying strong support from the governments and urban planners. With 10 winners across 5 countries, Virgin Hyperloop One are now working in partnership with each of the locations on how best to deliver the Hyperloop technologies in